Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hello, everybody. Good morning. I am your co-host, Roel Dionisio, alongside with Francois Verges. How are you doing, Francois?
Very good. Hey, how are you?
I'm doing well. I'm here at home in my garage. It's a little chilly, but probably not as cold as Toronto or London, where you're at.
Yes, we actually have some snow on the roofs this morning.
You got snow? Oh my gosh!
First of the season.
Wow, that's great. I guess we're officially into like the fall winter season, and so we'll be stuck indoors, maybe recording more podcasts. And I feel like we haven't recorded in such a long time. We've been both busy. I know I've been busy doing a lot of troubleshooting of Wi-Fi networks and also doing some new designs. How about yourself?
Yeah, I've been busy as well, traveling a little bit, and I'm working on a project right now, a challenging project. I'm trying to make it work. So, been busy as well, but it's interesting.
Nice. I always tell people you're a jet setter because you're always traveling to different countries, and I'm sure your passport's already full of stamps, and you need a new one.
I actually changed it last year, so I'm safe.
Oh, well, there you go. See, you recently changed it. Well, I want to thank everyone for joining us today because we're going to talk about the state of Wi-Fi 6 in practice, which is a presentation that we did at WLPC Prague. And so if you head over to the show notes, cleartosend.net/194, you will find a link to the presentation slides and also to the presentation video on YouTube on WLAN Pros. And so what we're going to talk about is a little bit of the presentation, and then hopefully we can try to add some updates to that as we talk about Wi-Fi 6 some more, because we've been using it a little bit more from since we did the presentation, but we'll go over what we found with Wi-Fi 6 from our testing. So again, you could watch that video if you go to cleartosend.net/194, and it's the at the end, near the end of the video, there's a live lab which went flawlessly, Francois.
Yeah, that was impressive. Yeah,
that was impressive, and maybe we'll talk about that first because I remember when I got there. I think that was the night I got there, right?
Yeah,
because we were up the next day, the night before, and so we're like, yeah, we'll do a lab, right? We'll just have people connect their Wi-Fi 6 devices, and they'll run an iPerf 3 test. And then Fernay was talking to you and was like, "Hey, you should probably test your lab before you go on stage."
Yeah, he asked me, "Have you tested the lab?" I'm like, "No," and I sounded like it's okay. Like,
yeah, you're pretty confident, right?
We're just gonna make it work. And Fernay's like, "I think you should test it." And then he's like, "What do you need?" And he got pretty much what we needed. The equipment, we got a whole bunch. We borrowed a whole bunch of WLAN Pi from Keith, and then a small switch, and then we had our Wi-Fi 6 AP. We needed a way to power it, so he lended us a PoE battery, and we pretty much spent the night trying to make work lab. And for some of the behind the scene stories, I actually forgot the admin password on my Jetson Nano, which is the small computer we use to do the packet capture, and we wanted to showcase Wi-Fi 6 packet capture. So that was like a key piece of the lab. So and I was like, oh shoot, I don't remember the admin password, and I had to rebuild the entire image. And the Jetson Nano uses Ubuntu, and it's an image that's a little bit bigger than a typical WLAN Pi image, and it takes forever to once you to burn the image on the SD card, it takes maybe 30-40 minutes, and then once you put it back into the Jetson Nano and you try to do an update and upgrade on the OS, it takes forever as well, and we did that pretty much the morning of the presentation.
Yeah. Maybe an hour before the presentation, you finished rebuilding the Jetson Nano and confirmed that it worked. but we had maybe 10 WLAN Pis all running iPerf 3 servers. You had your Jetson Nano. We had a switch to power up, to connect all these Jetson Nanos, and then the AP via PoE rolled that in. I mean, we tested it, and then we rolled it into the show floor. And at the end of the presentation, magically, it actually worked.
Yeah, we had everything, like you said, on the little trolley, and we put everything in the room. And then at the end of the presentation, we were able to make it work. We had Fernie helping us, telling us that, we needed to, start the lab. He was in the background telling me to move on in my presentation. And we actually had like 15, 16, 17 minutes, something like that.
Yeah, the timer was ticking. And then even I tried to motion to you like, hey, we should probably move faster.
Yeah.
Because who knows how long this lab will actually take. But it went very well because there were a number of people who had Wi-Fi 6 devices, whether that was mainly phones, Samsung phones, or they brought a laptop that had an Intel AX200 built in, and they were assigned an IP address. They did iPerf 3 tests, and then we were able to see that happen, and it worked pretty good, I thought.
The only thing that we had one hiccup, it's because I connected my laptop to our small lab network, so I could SSH into the Jetson Nano and then launch the packet capture and show everyone how we do this. But I forgot to disable my internet sharing on my MacBook Pro. So my MacBook was also a DHCP server.
Yeah, I think the Jetson Nano was also a DHCP server, right? It was the primary.
We had one of the Pi that was the core network. Remember?
Yeah, so we had your laptop ended up being up a rogue DHCP server on the network.
Yeah, exactly. So some of I remember Keith and Blake being like, "Oh, I didn't get
it wasn't working.
The proper IP address." I'm like, "Oh shit!" So I disabled my internet sharing, and then after they renewed their lease, they were able to get a proper IP address and get on the testing. Yeah, but we figured that out pretty fast. So
yeah, that's because we ran into that issue when we were testing it.
Yeah, and I needed this internet sharing to update the Jetson Nano when I rebuilt it, and I just forgot to disable it again.
Yeah, that's and it's completely fine. Like usually these demos go south, right? It doesn't go very well, but for us, there was minor hiccups here and there, but we were able to get it working with that much equipment, and it was mainly your work. I mean, you had like this vision in your mind, and I had no idea how you're going to set it up. But you just connected everything. Fernie helped a lot as well. He had everything you needed in a suitcase.
Yeah, exactly. Fernie, do you have this? Of course.
He just like gets a suitcase, and then all of a sudden he's got all these bags, and it's everything that he travels with for training. So thank you, Fernie, for helping out there.
Yeah, he had all the cables with all the different ends and adapters you could think of.
So in this recording, we're going to talk about some of the stuff in the presentation, and in that we're going to talk about the process that we went through. So that is three things. It's really theory, the equipment or lab, and the testing. And so as of this recording, Wi-Fi 6 or 802.11ax still is in draft version 4. And I don't think it's expected to be an actual standard until late 2020. They keep pushing that date out, but that's what we should be expecting right now. And right now, I think you put a graph into the presentation, Francois. We're like a little over the peak of inflated expectations, right? So we're on the down curve now before we get to that plateau of where productivity is, kind of where 802.11 AC sits right at this moment. Yeah,
and if you're thinking about or talking about the type of equipment we have available today on the market, we're seeing the first wave of AX access points coming out. So now like this is beginning of November 2019. Pretty much all vendors have a Wi-Fi 6 access point out, and this is the first wave of Wi-Fi 6 access point.
Yeah, so we're going to see a bunch of changes happen between now and when the standard comes out, because being that this is first wave, you got to expect that there's going to be issues. And it's just going to happen, right? It's a new technology, new hardware for APs and clients. No one knows how this is going to work out because first wave, I mean, we know that Aerohive is already like end of lifing or end of sale some of their first generation Wi-Fi 6 access points. And that's because there's either new chipsets or there's new firmware that came out that you could apply to the chipsets. And it's going to be the same with every vendor. And what's interesting is we're now seeing more consumer and Wi-Fi 6 access points hitting the market, right? There's a lot of announcements and soon the
Asus,
home,
Linksys,
they all have it. And in the home, I think that's where we're going to see Wi-Fi 6 first, right? We'll have people's phones get updated and then soon they'll have it in the homes. And I think that's where a lot of that maybe development will come through and in interoperability to see how that works. And then it'll make its way to the enterprise.
And you mentioned the the bugs we might see with the first gen of APs. Also, like some of the features not supported, we might see some of this because of the first gen. You mentioned the chipset not supported some of the features. We did have, if you listen to the YouTube videos all the way to the end, and David Coleman gave us some details about the chipset and how the chipset manufacturers are actually just releasing their SDK, so the vendors can actually reuse some of the features that wasn't available to the vendors before. So everything is still work in progress, and maybe we'll talk about that again when we talk about OFDMA.
Yeah, we'll talk about that more with equipment and OFDMA. So first we'll dive into the theory because we'll talk about what it took for us to try to understand Wi-Fi 6, right? So we call it Wi-Fi 6 now because that's the marketing, and we'll get to that in a bit. But to start learning Wi-Fi 6, you have to start with the theory. And so that means you have to go to the source of all information regarding 802.11ax. And that means starting with the draft. So there's a draft document by the IEEE 802.11ax, and it's draft 4. When we started learning this, Francois, we started with draft 3. And so what were your thoughts? Did you notice all the changes they made in draft 4?
No. No. I didn't read the changelog. Did you read the changelog?
I didn't either. I just dove in. I was like, I don't care about the changelog. I need to reread everything again.
Yeah, so it's my first thought was, oh man, this is complex.
Yeah, right away, right off the bat.
Yeah, you could see it's a big step in the way Wi-Fi network will work, especially with all the new technologies they're introducing, all the new enhancement they're introducing to AX. So AX is just not one small enhancement. It's I would say it's like a series of different technology that they're trying to add to the standard to improve its efficiency, improve the way we handle IoT devices, make it future proof so we can handle high bandwidth requirements in the future. They were thinking about AR, VR, these type of applications, and also improve the overall efficiency of today's AC network. So you can see that each different enhancement is trying to cover one of those needs, and it's like these overall enhancement makes AX or Wi-Fi 6. So it's not just one small thing; it's a whole bunch of smaller things that comes together and bring you this better efficiency.
Yeah, and of course, like OFDMA is going to be a big target here, but I do think we'll see maybe a wave 1, wave 2 for OFDMA features, especially when it comes to probably the uplink feature. And a lot of the vendors will tout these features in their access points, but when we were testing it, right, we could not see that. And so we'll kind of go into that when we talk about equipment. But when it came to trying to understand this draft document and how complex it sounds, especially the language and the algorithms that they put into this document, I had to resort to other resources to try to get more of an English, dumbed down version.
Friendly.
Friendly for engineers like me who's not the brains behind the draft. Like those are really smart people. And so one of the first documents that I read was the Aerohive's 802.11ax for Dummies. I thought that was a really good document, which you could download online for free, I believe.
Yes. Yes, so that was really good. And then alongside this document, you also have the new chapter in the CWNA book. I think it's chapter 19.
Yeah.
And it's written by David Coleman as well. And I think he wrote the dummy book for Aerohive as well. So it's really nice because it gives you an overview of what you'll see in the standard. Also, a document I really liked was the Aruba white paper on AX.
That document was very technical, but had a good balance. Yeah. So I thought, and it had a lot of really great visualizations in the document to help you understand what OFDMA meant, right? How would you explain that to somebody in a way where it made sense? So I think Aruba did very well with that document.
And also when I read this document, I was like, oh, I think I missed some part of it when I read the draft because they were providing more information. So it felt like the person that wrote the white paper was also working for the draft. You know what I mean?
Yeah.
It felt like it was an engineer involved in the process. So they would give you information that actually are useful from a technical side point.
Yeah, and I will say, like, people who are writing the draft or making this in this 802.11ax working group, they are people from these vendors that work together on this document. And I think it might not be the same people who write these other resources, but these companies do have a say in developing that 802.11ax. So I think that's why a lot of these vendors come out with equipment so quickly, is that they understand.
They're involved in the process.
They're heavily involved, and that's why they come out with these resources first. And the other document that I read was Cisco's 802.11ax, the 6th generation of Wi-Fi. But I didn't find that one heavily technical. I think it was more of an informational document, but it did provide some value. I think it was more of a high level for me of a document, but I mean, it got the message across.
Yeah. And then a couple of white papers from the Wireless Broadband Alliance, WBA. I found them very interesting, especially for what we could expect of Wi-Fi 6 in our network in practice. Is it going to help us? Are we going to have to design it differently? Type of use cases. So they go through those type of topics on the white paper, and it's very interesting.
Yeah, and the same vendors are in this group too, Wireless Broadband Alliance. Yeah. And I remember somebody described the difference between the Wireless Broadband Alliance with the IEEE and Wi-Fi Alliance. And it sounds like these guys were more about moving things along faster, right? This group was about moving things along faster and getting you information that you could use out in the field. So they had a really good document about how you would be deploying Wi-Fi 6, for example. And I thought it was really good.
Yeah. Yeah, and they give you PKI to look for. It's very interesting. It's concrete.
And then the last document that we highly recommend you guys test out, and this came out of WLPC Prague, was Germund's Airtime Calculator, which I thought was, I think his presentation was my favorite one out of all the presentations.
Yeah, very impressive. Yeah, very impressive. So he came out with this Airtime Calculator to, pretty much estimate how much time will OFDMA and OFDM, I guess he did both, but OFDM and multi-user OFDMA transmission will take over the air. And he pretty much reverse engineered the process looking at the draft and explained that to us. And you can download his Airtime Calculator, which is pretty much Excel sheet. You can download it and play it with play with it to understand how it works.
Yeah, and I think that's one of the best ways to learn how anything works is reverse engineering, everything that you've read out of the IEEE, and he's done it. And what you can do now is actually reverse engineer his work with the Excel sheet to understand how Wi-Fi works in general. And so what's neat too is his document, you could reference it with your document, Francois, the MCS table. And so if you do the Wi-Fi 6 Airtime Calculator and you look at the MCS rate, you could tie that with what you have in your MCS table. And so we have multiple documents that we could use to confirm a lot of what we think we know. And I think that's it's really interesting to see like the community come together on this aspect to create resources for everyone available, because we're not seeing this from the vendor side, for example.
Yeah. And it was funny when Germont, I remember when he was working on the Airtime Calculator, he sent me a message and he's like, hey, I used your MCS table to validate my work. I'm like, oh man, I trusted my math. He's like, oh, it's okay. I came up with the same results. I'm like, okay.
You're like, yeah, there you go. All's good. And so this brings us to, what did we get from the Wi-Fi Alliance? Because I figured we should be getting more from the Wi-Fi Alliance. And so the Wi-Fi Alliance is really marketing for wireless. And so that's why we call it Wi-Fi. And they've taken the name 802.11ax and made it more consumer friendly to call it Wi-Fi 6. And so that's why we're calling it Wi-Fi 6 moving forward. I mean, we'll reference 802.11ax here and there because that's the technical term. But then now they have this Wi-Fi 6 certification, right? They recently came out with, I think it was maybe 1 or 2 weeks before WLPC Prague that they came out with the actual certification, Francois?
Yeah, I think it was mid-September 2019.
Okay.
And they came up with the new naming a year ago, October 2018.
Yeah, so looking at the Wi-Fi 6 certification, it's interesting because it's not a standard yet. We're still maybe over a year out for it to be a standard, but now they can certify devices and tell you if they're going to support a set of requirements that Wi-Fi Alliance has defined, right, to meet those requirements. And so there's 3 different kinds of categories that a device can be lumped into, and that's either Wi-Fi 6 compatible or a certifiable or a certified device, right? So the Wi-Fi 6 certified device is what you want to look for if it's going to support all the requirements from Wi-Fi Alliance to be Wi-Fi 6 certified. And so we can put that in the show notes what that Wi-Fi 6 certification means. But there are a lot of devices that are Wi-Fi 6 certified. And then you must be asking, what does it mean to be compatible or certifiable? And so I think that just adds more confusion to the mix. But that's because there are devices that came out prior to this certification. So they have to categorize those somehow.
Yeah, you're right. And some devices came out, some AX devices came out before the Wi-Fi Alliance had defined the different requirements for the Wi-Fi 6 certification. And like you said, for the requirements, some of them will be mandatory. So if you want your device to be Wi-Fi 6 certified, you have to meet those requirements. Mm-hmm. And we try to list some of them, and then some of them are optional as well. And what was a challenge for us was to gather this information, because if you're not a member of the Wi-Fi Alliance, you don't have access to all the technical document that tells you how to test your equipment, right? That don't give you all the requirements if you're not a member. And to become a member, you have to pay. You have to pay money, right?
Yeah.
I think there's different levels of membership, but I think the cheapest one is like $5,000, something like that.
Yeah, I think we both had a discussion like, should we pool our money together and become members of the Wi-Fi Alliance? But then we were thinking we don't have time, so it'd be a waste of money to even try to, participate in this just to get documents. And I didn't think it was a good investment of our money.
Yeah. So what we had to do is read the publicly available document, which is mostly marketing documents. But you can, well, it's true, no?
It's true. And this is why it's funny, because we have to, there's no straight answer sometimes. And so you're left to make assumptions.
Yeah, so that's what we had to do, and then come up with the list of mandatory optionals. So we put that out there. So So what you see on our slides, if you look at our slides, it's pretty much what we came up with based on how we interpreted the publicly available document, but that might not be exactly what they have in the technical documents.
Yeah, so it might change in the future, right? We might have a new episode where we clarify things like, here we are. Here's where we are today. Here's everything's clear now. Here's what we see.
Yeah, hopefully we can have an episode with some people from the Wi-Fi Alliance and they can go over those type of information. Maybe we can have a conversation with them regarding those type of challenges we face as, engineer in the field. And maybe one day we could have a solution or something. Not everyone is interested in having the technical details of the certification, right?
Yeah. Some people just want to know, like, I need a Wi-Fi 6 certified device. Is this one? Is this AP pass that test? So really the short story is compatible means that the access point or I guess the device supports some AX features, but not all the mandatory features required by the Wi-Fi Alliance. The certifiable device supports all the mandatory features, but it hasn't passed the certification test, right? So it's certifiable, but it hasn't passed the test yet. And then, of course, the Wi-Fi 6 certified means it supports all the mandatory features and it passed all the tests by the Wi-Fi Alliance, so they got the certification.
Yeah, exactly. And when we did the presentation in October, right? Early October, we had 42 devices certified Wi-Fi 6, so that includes the AP and the client devices. Today, as of November 1st, we have 95. Whoa. So we can see that the Wi-Fi Alliance is in the process of certifying all these devices. And you might have devices that were certifiable that are now certified.
Yeah. So we're going to see a lot more happen. And so we're just keeping track as much as we can with what's out there, what's changed. Is there a device that maybe fits the needs for us with testing? And so that goes well into the next section where we talk about the equipment, because once we read through this theory, we need to see the theory in action, right? So we need to get our hands on Wi-Fi 6 equipment. At the time when we were getting a hold of equipment, there wasn't very many devices to get, right? So being that we were part of the Cisco Champion program, I think one of the first devices we got was a Cisco Catalyst 9115. I got a 9115. Francois, you got a 9117?
Yes.
And so that was the first Wi-Fi 6 access point that I got a hold of, or actually no, I actually got an Ingenious first. So we had two APs that we were able to test, a Cisco and an Ingenious. And then you had a Samsung S10, which was Wi-Fi 6 certified.
Yes, I had. So actually, the first AP I received was the Aerohive.
Oh, okay.
Aerohive, AP630, and then I got the 9117 from Cisco, and then the two APs from Ingenious, 357 and 377, and that's pretty much the one I used to do my test.
Yeah, so I tested both on the Ingenious and the Cisco 9115. I ended up getting a hold of a Samsung S10, and then I also got an Intel AX200 because I have a Lenovo ThinkPad, a T440, which I was able to upgrade. And then I was able to test full Wi-Fi 6 connectivity. And so we were using that equipment in order for us to validate some of the theory, right? And then we came to certain conclusions because we did very basic tests. We weren't very complex with the test. It was more of, okay, let's do some basic throughput tests. Let's use iPerf. Let's use speed tests. Let's see if we can get into the details of the access point and see what data rate we're getting. Are we able to get 1024 QAM, for example? What else were we testing? We used a Sidekick to see if we could get OFDMA, for example. Those are the basic tests that we were trying to do.
Trying to see if Wi-Fi 6, like if you had like both Wi-Fi 6 and Wi-Fi 5 devices onto the same AP, would you have the same type of performance? That's a couple of tests we did as well.
And so we did the testing. We stuck with simplicity just to test functionality. And then really want to see, is it advertised? Like, are we getting what we're being advertised, right? Are the marketing words on these websites and data sheets, does it match with what we see in the real world? And can we capture some frames in order to support these claims, right? So I feel like I'm rapping.
Yeah. So and also like the good thing about those simple tests as well is that it forced us to see how everything was operating. And as even as an engineer, as an operator, how do you configure it on the controller? How do you validate it on the AP side that you're indeed using Wi-Fi 6? Because, if we kind of take it for granted today that, whenever we configure the access point, everything is going well. But for these simple tests, we actually wanted to validate that, okay, if I configure my AP to use Wi-Fi 6, is it really using Wi-Fi 6, right?
Yeah.
So we went through that process, and that also helped us to understand, how do we validate that? Which command do we need to use? Can we have this information on the GUI? Can I see it directly from my device? And all these type of, small operation changes that you guys will see in the future when you start deploying Wi-Fi 6 on your networks.
Yeah. So the first challenge that I ran into with testing all of this was I was unable to capture any frames. Or actually, that's not true. I was unable to capture most frames that were Wi-Fi 6, right? The only frame that I could ever capture was a trigger frame from the AP, which looked like it was trying to schedule OFDMA. But that's the only frame I was able to see from the AP to the clients, because I had two clients, the Samsung S10 and the Intel AX200. And on top of that, I was using a device that was not Wi-Fi 6 to capture those frames. So I was only going to see some frames.
Oh, okay. Yeah, I was going to ask you, how were you capturing those frames?
Yeah. So then that was the first challenge, right? And then the second challenge was I was trying to use the Cisco's Catalyst 9115 to capture frames, right? So it's a Wi-Fi 6 access point, and with your controller, I was using this Catalyst 9800. I know you could put the AP into sniffer mode, which means you could capture frames. And so I was using that, but I still had the same challenge, which was I can only see that trigger frame from the AP. And to be clear, I was using a second, another AP, while the Cisco Catalyst 9115 was, I had one AP operating and serving the clients, and I had another AP in sniffer mode. So I wasn't able to capture any Wi-Fi 6 data frames. So I could only still see that trigger frame. And so I made an assumption that OFDMA was working, but I couldn't tell if the clients were doing OFDMA, right? I could only see that the AP says, here, do OFDMA.
Scheduling it.
Yeah, it was trying to schedule it. Like, it was telling two clients, here's how many RUs you get and how many RUs you get. But I couldn't confirm it with the clients at all. And so it turns out that the Catalyst 9115, 17, and I guess the 9120 will probably not be able to capture those frames. So I can't confirm for the 9117 or 9120 because I don't have those APs. But it looks like maybe it's a limitation with the chipset or the software, firmware. I don't know. It's definitely not I don't think it's a Cisco thing. It's just that we're still early with Wi-Fi 6, that maybe that feature isn't implemented in the chipset itself.
Yeah, and I think I can relate to that because I had a similar experience. I was trying to use my 9117 to do the packet capture, and I had the 9800 controller running on the VM on my laptop. I could actually use the AP as an access AP, just typical local mode. But whenever I was putting the AP in sniffer mode, it wouldn't rejoin the controller. It would just loop, and then like something would happen in the booting, and it would never join the controller back in sniffer mode. So I actually tried to connect it for maybe a day. I spent a day trying to make it work, and I was like, okay, it's not going to work for me. And then I had I had the Galaxy GS10 as a client, and also I purchased the Jetson Nano from NVIDIA with the AX card. You can actually install the AX card into it. So I had that, and then I came across a blog where one guy was explaining how you could use that to do packet capture. So I was like, okay, let me try it out. And I was actually able to do packet capture from the Jetson Nano and using the Intel AX card. And what's good about the Intel AX card, if you have it on the Ubuntu, is you can actually put it in monitor mode and then do your packet capture. And because it's an AX card, you'll be able to capture all the AX frames, right? So I ended up using that as a setup because it was the most reliable way to do AX packet capture. I would just like set it up on Ubuntu, place it in monitor mode, configure it on the channel I wanted to capture on, launch the packet capture, and then with my GS10 I would generate some traffic, and then I could save all of that in Wireshark and have my AX packet captures. So it was really good. It works. I found that it worked really, really good, better than doing a packet capture from any other devices. The only thing is that, I only had the one AX device left to do my testing. Yeah.
So I think that's our best bet right now, is using the Jetson Nano until the sniffer support comes from all APs. And I haven't tested my other APs for that yet, and just trying to figure out how to make that work. So one of the examples is I got an Aruba AP that's Wi-Fi 6, and I didn't know how to do the packet captures on that, but I managed to get into the CLI to see what kind of data rate is being used between the AP and the client, which I thought was really great. And this is how we were able to confirm 1024 QAM, was looking at the CLI and seeing, okay, show me client statistics. And so I would look at the Wi-Fi 6 device, and then be able to see that, hey, here's the AP trying to communicate with the client, and it's using 1024 QAM. And I would also see the receive rate that the AP negotiated. And sometimes that would be 1024 QAM, sometimes it wasn't. And so it would dynamically change here and there. But being close enough to the AP, it looked like it was pretty easy to get 1024 QAM.
Yeah, I was able to get 1024 QAM as well pretty easily when I was close to the AP. Even if I was like, a couple meters away from the AP, I was still able to get 1024 QAM. Testing with the Ingenious APs, since we had both the 2x2 and the 4x4, I was able to see that. You can see my daughter, right?
Yeah, I can hear she's
she's coming from me.
She wants you. I mean, we'll wrap up real quick. So, why don't we just go to the general observations?
Yeah, don't worry.
It's okay. Oh, she needs to be consoled.
Yeah.
Here, I'll start my general observations.
Okay.
So the general observations that I saw were that firmware is going to be our limiting factor here, because not everything is implemented yet on each of these access points or even the devices. But I would say that we should look to the access points to figure out what is supported. And in our observations, we saw that while features could be enabled, say on a controller, you might not necessarily see that. And so there's a lot of visibility that we don't have yet into validating some of the operations of Wi-Fi 6, but we need to wait for the vendors to work with the chipset manufacturers in order to get all of this working correctly, right? And as we mentioned earlier in the show, during the WLPC presentation, David Coleman, who's from Aerohive / Extreme Networks, he was stating that they just received at that time during the conference, they just received the SDK from the chipset manufacturers, which means they'll be able to implement more Wi-Fi 6 features. So that's going to be our limitation there.
Yeah, and I think you could expect to have more, software version release on your AP, and then if you have those new firmware release, try to look at the data sheet and see what new Wi-Fi 6 feature they enabled or added to the mix, and you can try to see what's different.
And then for 1024 QAM, it works. I was able to confirm it on the AP. I couldn't confirm it over the air with the frame capture, but the AP was negotiating a data rate, which looking at Francois' MCS index or chart, I was able to confirm that MCS 11, what I was getting. But when I tested it, say I went to another room where I placed attenuation between the AP and the device, I was not getting 1024 QAM. And I wasn't that far from the AP. It was just one wall that was in between me, my device, and the AP. So it looks like you would have to be line of sight with the AP possibly. And it's going to depend on, how you mount it and maybe also the type of AP, who knows. But I was only able to get 1024 QAM line of sight and pretty close to the AP.
Yeah, I think that's one of the limitations we'll have. Also, I would like to see, it's nice in our office, where we have the AP on the table and then the client next to it. But it would be interesting to know in the real environment, in the real office environment, how we could know how this is going to play out. We've seen some, heat map from vendors showing us, the impact of 1024 QAM, but in the real life, I like to test it for myself as well.
Yeah. And then OFDMA, I was not able to capture OFDMA. I couldn't really tell. It looks like I captured it, but there's no way for me to confirm it since I can't get the frames over the air, right? So I would do tests, and it looks like it was OFDMA when I had two devices doing iPerf 3 tests. And I think I have a video of it where you could see it looks like OFDM, but then you could see on the 20 megahertz channel, half of that looked different than the other half. It was slightly different, but again, it can't confirm it. And also some devices don't even, some APs don't even, aren't using OFDMA yet.
Yeah, so actually, at WLPC after our presentation, we did a Wi-Fi 6 party at night, and we had a couple of APs we tested with the Rockets AP. That was the first AP that got certified by the Wi-Fi Alliance. But the way we're using the AP wasn't enabling OFDMA, so we tried to make it work, but it didn't work eventually. But it's just because we didn't configure it properly that night. And then we tried with the Mist AP. And with the Mist AP, we were able to get some OFDMA uplink traffic and capture the proper frames. Maybe we can put some more details in the show notes on how you can validate that you indeed have OFDMA in action. And for the Cisco AP, I think you have the release the new code, right? The AirOS 8.10.
Yeah, I haven't been able to test that yet.
Yeah, it's supposed to be to support OFDMA as well. So if you have that version and you have Wi-Fi 6 AP, you should be able to generate some OFDMA traffic and capture it, to look on the spectrum what it looks like.
Yeah, I guess I should try that since I have a controller that could support 8.10. Because I've been using the 9800 for the most part, and I'm waiting for that code to be updated because it does say it supports OFDMA and you have the options to turn it on and off, but maybe it's just not working right with the AP. But maybe with 8.10 out and they're saying that OFDMA is supported, maybe the 9800 code will come out as well, because that's all I'm waiting for, and also waiting to see. I've just been trying to use the 9800 basically is what I'm trying to say, because I want us to create some episodes with the 9800, and I've just been barely getting to actually deploying it where I understand the concepts.
Yeah, the tags and all.
Yeah, tags, policies, whatnot, and how it works when you change them with the APs. But I mean, that's our general observations with 802.11ax or Wi-Fi 6 is that it's not ready. Yeah,
we still have in practice. We still have a couple of months to go, maybe. Yeah. Now that the iPhone 11 is out, we will start to see more and more Wi-Fi 6 client devices come out, and that should speed up the process a little bit.
Yep. Well, that's it for our show, guys. If you have any questions, comments, head over to cleartosend.net/194. See you guys.
Thank you. Have a good night or day.